name's Justin. I'll start a little bit about myself. I first started writing code back in 1991 on a 286. From there, I progressed to doing very useful things in high school, including building a fake DOS shell and using some social engineering with a computer science teacher so that we could capture the admin password to the Novell network and install Doom so we could play multiplayer Doom during school break. I did not go to university, so you shouldn't listen to anything I say. I've been building microservices since long before they existed as a concept. Hi Corba, and hi to anyone who got to use Corba back in the day. But RPCs and microservices really aren't new in the world of software. They've just shifted form a bit. Right now, my favorite programming language is Kotlin, but I really want to give F# a try. So Cornel, you don't have to like me anymore. It's fine. Lately, I work with big corporates setting up development teams for them. So most recently, setting up large digital hub for a big organization, dozens of developers, all writing software for the first time, so quite new for them. I've done this a few times, and I really like to write code, and I want to share some of what we've done to make their lives better, and hopefully you can use it to make your life better as well. So if you're having to work with microservices and Docker and you're deploying it to Kubernetes, you might be doing something like using Docker Compose locally or just running the service by itself. And while you have 1, 2, 3 services, it's quite easy. And you might have some dependencies, databases, Redis, RabbitMQ, even Kafka. So you want to bring up your service, you want to bring up all the infrastructure that you need around that service. When you get to reality, it looks a little bit more like this. It's not just one service anymore. You've got tons of services, tons of infrastructure dependencies. Things need to speak to one another. You've got your traffic going through an ingress to get to your service, and you don't have any of that on your local development machine. So you're kind of building in the dark, and you're hoping that when you get through to production, things are going to work for you, and hopefully you don't look like this guy down at the bottom. So I hope that everyone here is able to have a bit of a CI/CD pipeline to get their software out to production. If you're using Kubernetes, big punt for Azure here, but Azure pipelines, something I've used before, continue to use. It's a great way to sort of build your software. You might be using Jenkins or GitLab or anything sort of similar to get that done. And maybe you're deploying to Kubernetes at the end of your pipeline. Maybe you have more than one Kubernetes environment, but you're certainly going to have some sort of data stores that you're speaking to, and how you were able to replicate this on your development environment is going to lead to what sort of success you have later. So here's what your developer experience might look like, using Visual Studio Code, IntelliJ, some kind of IDE to build your software. You're deploying that to, or you're committing that and pushing it to some sort of Git repository. It could be GitHub, something inside Azure, GitLab, could be really anything. You're then doing a build of your software, followed by a deployment. And that's where you sort of hit reality. So you've been working in isolation down here. You may have been running some infrastructure dependencies, standalone or as part of Docker Compose, but you're not capturing any of the sort of intricacies of your production environment. If you're deploying to Kubernetes and you work in an organization who take security very seriously, you're almost certainly running Linkerd or Istio inside of your cluster, and you never would have done that on your local machine, right? So you aren't working in the same kind of environment. And what we don't want to have happen is this kind of reality where you get to deploy your software and later on you find that stuff just didn't work out, right? So what I'm going to show you is a little bit about what Skaffold does. Skaffold is a tool built by Google. They've been running everything in Kubernetes for quite a long time now, and they face this exact same problem. You know, how do they ensure that developers at Google can work in Kubernetes on their local machine, or, you know, code on their local machine but get feedback from a real Kubernetes cluster very quickly? So Skaffold supports both. You can plug it into a local Kubernetes cluster running on your laptop, or you can plug it into a development cluster that's just for you or that you share with other people. So there's a few options there. And I'll focus on JVM-based services. So I'll show a little bit of Spring Boot running, as well as a little bit of Micronaut, and then Angular and React as web frameworks, and how it can work quite well with all of these, and how you can have, you know, real fast feedback. You can still debug. Your hot reload still works for your web applications, and you're running in a Kubernetes environment that can be configured, you know, to be really close to what production might be looking like. So first up is, what is Kubernetes? So, sorry, what is, oops, wrong window. So Skaffold is like I said, a tool by Google. It is, it has two parts that you're probably going to care about initially. It has a build description, and it has a deploy description. So the build is really about where to find the software that your team needs to be running locally to have the whole environment up. And then deploy is how to deploy that software, as well as any other infrastructure components that you might have. So, you know, if you are running anything in the JVM, then you can point it to a Gradle or a Maven context using the Jib plugin. Jib is another tool by Google, and it basically does containerization of any sort of JVM service. I've used it successfully with Spring, Micronaut, Ktor for Kotlin, and I think you can get it to work with Quarkus as well without too much struggle. So it really supports a whole variety of things. It's pretty smart by default. I haven't had to do any custom configuration. It just understood how to package the application. It uses a distroless JDK image to do the build. You can override that and use a custom image or any other image that you like, but it's really smart out the box. So if you have a Gradle configuration, you end up just with one extra little Jib section. If you're using Maven, then you should probably be using Gradle instead, but it can do the job there as well. It's pretty straightforward. Then you need to have a Kubernetes deployment descriptor. So this is a pretty basic one, but you know, if you wanted to lay in extra things here, as long as your Kubernetes has the required things available in it, you're good to go. So, you know, I've got an ingress, I've got a service, and I've got a deployment here. You just have to tie up your image names to match with your scaffold definition, and also with what's happening inside of your build files. And then once you've done that, if we go back to the scaffold file, you'll see we've got the image names here. That's what it's going to deploy, where to find the code. And if you're using Jib and you're part of a multi-project Gradle build or a multi-module Maven build, then you just need to specify your project. Also quite straightforward. For things that aren't JVM based, it supports quite a few other build systems. So Jib gives it Gradle and Maven. You can do any kind of Docker file build. You can run a custom script to do a build, or it supports build packs as well. This is all available out of the box, really easy to set up. If we take a look at, say, a React application, this is a pretty straightforward build. From Node Alpine, we want to copy in the package JSON, do an npm install. Then we want to add the rest of the source. This is just so we have some decent layering in the Docker image, and we don't have to go ahead and rebuild when anything that isn't part of package JSON changes. And then we do something which is quite clever using the file synchronization. So, they were really, it's all about developer experience. So what Skaffold can do is it can do file copies into a running container inside of a Kubernetes cluster. So here, if anything changes under the source directory, Skaffold is going to not rebuild the application. Instead, it is going to just copy these files across. And then Webpack or any other system you've got running can do a rebuild, and hopefully you get hot reloading working out of this. So we'll give that a try just now. There's some additional configuration around deployments. So this is just saying that wait at least 4 minutes for the build deployment to stabilize. This might be useful if you're doing things like bringing up a really complicated bit of infrastructure. Maybe you're bringing up Kafka or an Elasticsearch cluster or something really crazy, and you need to wait for all of that stuff to come up and for everything to stabilize before Skaffold just gives up and says, look, your software is not running. You probably need to take a look at something. And finally, what's pretty cool about this is we've got a MySQL that we're going to bring up. So if you have MySQL or any other kind of SQL server, you can get this to work quite easily with Postgres. I've done it with Oracle as well. Bringing up a container with your database running is super useful. And before, you would have had to manually set up all these things. So really, the challenge I was faced with was there are 45 developers, who have some container knowledge among some of them. Some don't have container knowledge at all. Some have never run MySQL themselves in their lives. We're also using Redis. We have a need for Oracle as well. So there's a whole bunch of complexity, and I don't want developers to have to deal with that. I want developers to run one command and be productive. Hopefully, the dream is, can we get a new developer on board and have them bring up the environment locally on their laptops really quickly and in a way that gives them working software that they can then begin to modify and contribute towards. A real big push behind this was, COVID obviously happened, and that meant taking 45 developers fully remote and doing that in a week. So I had somewhat started out with this, but it really took a week to get it all done. We have about 15 microservices running there, as well as a web front end. And we also have mobile developers working against some of the services. So we had sort of a mix of developers, a mix of skills. We needed to get everyone remote. We had problems getting infrastructure provisioned for development environments, testing environments. This was quite early during the project. So we needed a way for developers who were sitting next to each other to all of a sudden be sitting, you know, thousands of kilometers apart in some cases, and have them work as if they were working side by side. So we did a couple of things. One is spent, you know, about a week and a half just making sure Skaffold worked super smoothly. This was a little bit more intricate because we needed to have VPN connectivity to access some internal systems. There were, you know, some developers had Linux, some developers had Mac, some developers had Windows. So what we ended up doing was creating a Vagrant configuration that looks quite similar to the one I'm going to show you now. So if anyone's used Vagrant before, you know what I'm talking about. If you haven't used Vagrant, it's a way to kind of define virtual machines and bring them up really, really quickly. So head over to vagrantup.com if you haven't used Vagrant before. And then what we wanted to do was bring up Skaffold inside of this Vagrant VM so that, you know, people could get started really quickly. They didn't even need to necessarily install Docker on their machine if they were just working with the web development, or if they're a mobile developer, there's no need for them to install Docker. They can run pretty much one command, get the Vagrant VM up, and then run all the services locally themselves. So, you know, there's a little bit of a setup script. It does, you know, installs Java, installs ngrok, and the reason we had ngrok is so that the developers could collaborate, so that a mobile developer could quickly point the app to a backend developer's API, and they could collaborate that way, so that a product owner could see the web application running and do a bit of a review, and just so that people could share their work in an easy way. Install Docker. So this is a little bit important when working with Skaffold. You need to have Docker running if you want to push the builds into your local environment. So Skaffold doesn't. So Jib can do a build without Docker. It doesn't use Docker build to do a build of your images. We obviously have the web apps running as well, so we need Docker to do that build, and we also want to push the images into our local environment so that they're accessible. Now, if you're not working locally, Skaffold and Jib can play very nicely working with a remote repository and a remote Kubernetes as well. But in our case, we need to have Docker installed. Then we needed a local Kubernetes as well. So if you're running this straight on your laptop, and I'll show that running in a moment as well, you can use Docker Desktop if you are running on Windows or Mac that has Kubernetes that comes with it out of the box. You can enable that Kubernetes and you're good to go. About the only bit of configuration you need to do is to add the Nginx ingress to your Docker desktop. The other option on Windows, Mac, or Linux is you can use Minikube. Or finally, if you are running Linux, you can just use Kubernetes directly and install K3s or whatever else you want to have Kubernetes running on your local machine. So we use K3s. It's quite lightweight. You can get away with about 500 megs of RAM to run the whole Kubernetes cluster. It's quite lightweight. It supports things like local path storage provisioning, which is quite cool. Minikube also supports this. Docker Desktop doesn't, so just depending on your needs. If you need to do like persistent volumes or things like that, you're going to want to use Minikube or K3s. Then lastly, we install Skaffold on this Vagrant machine, a little bit of a nicer shell because that's always better. And then you're good to go. And you've got Skaffold up and running. So we can see that running over here. I'll just run it one more time. This is inside the Vagrant VM, by the way. I upped this just before the talk. I'll be sharing this repository on GitHub, and we'll put a link into the meetup description. So you can grab this for yourself and see how it all works. So basically what's going on here is Skaffold looks for files to watch because it wants to rebuild every time there's a change. There are two ways to do this. One is automatically, so it's watching either using file system events on Mac or Linux, or on Windows, or it is polling, or so that's if you are running with like a file share or something where it can't do file system event listening. Or finally, you can do manual triggers. So maybe your machine's a little bit slow, or the build takes a long time. You don't want to like change a line of code, save the file, and have it rebuild immediately. So there's a few options there. And that was my React killing the screen. So it will, one, look for any cached images. It won't rebuild if there's been no changes. If there are changes, it'll rebuild the things that have changed. And finally, it does the deployment. And it really understands Kubernetes very well. So if you have things like, ready checks to understand if your service is up, it's going to first wait for a new instance of a service to be ready, and then it will cycle the old instance out. So it's really very smart. You can have sort of zero downtime in your local development. It's it's really, really great that way. This is running inside of Vagrant, but what I want to show you now is, let's run it inside of the IDE real quick. And I think I just spotted a small problem in my Gradle file. It should be Micronaut. So if you are using IntelliJ, then there is a plugin that does what we need, and it's released by Google. It understands skaffold. It understands deploying skaffold into local or remote Kubernetes environments. It understands the debugging that comes with that. So you can really debug into your code, no problem at all. And Skaffold supports debugging for JVM, Node, Python, and Go. So there is some support for C# that I've seen, but it's sort of a little bit not super official in the documentation. But there certainly are some things on GitHub if you go read on the issues and the pull requests. So there's something coming there soon. I really hope it does arrive soon, because that would be quite super. But you'll go ahead and add Cloud Code plugin by Google to IntelliJ, and then you can sort of just run or debug the application. And you'll see it start Skaffold and says many of the same things that we saw inside the Vagrant VM. You can also just run Skaffold on your local command line as well, but that's a little bit less interesting right now. So it's going to see what it needs to rebuild, probably everything, and then we'll get going once that's there we go. So it's building Micronaut because I had a change in the Gradle file. And we'll go ahead and hit the service after that. So it is deploying everything to Kubernetes, waiting for the deployments to stabilize. If you are interested in what that is, it is just if you just run this command, kubectl get pods, you'll see that some of them are in init state, some of them on container creating, and it's just going to wait for these to finally come up, and then it will have stabilized the deployment and we'll be in a good place. So we're waiting for Mysql to start. Now it's just the Spring application running because, of course, we're waiting for Spring to start. I don't know what to say. Once everything's start, it'll begin to stream the logs to standard out. So any kind of log lines that will be generated by the running applications, you get to see them in your standard out. It tags each container with a different color so that even though your log lines are sort of all munched together, you can see which container logs are from. So Spring is red here. Angular doing its compile of TypeScript is in yellow. React's already up because, of course, it is. If we could make Angular compile faster, I'd be much, much happier with life. But let's just wait. And then what we want to do is actually run a, let's run one of our APIs. So there's a Kubernetes ingress defined for each of the services that we're deploying, and each service is doing the same thing. So I've got a shared library here, and I wanted to show it off in a moment, just how well Skaffold integrates with Jib and understanding what needs to rebuild, even if you have shared dependencies. I don't know if anyone here is having to use a is using a mono repo in their world. But if you are and you're doing dependencies as part of a mono repo using Gradle multi-project, then this is quite cool. So we got a little dice roll service. Basically, you can say how many dice and how many sides they have, and with some luck, we get a response, and the demo gods are kind to us, and they are. So we asked for 4d10, so there's our dice rolls. Super cool. And we should have the same thing running out of the Spring service as well. And we do, so that's great. But let's say we want to go ahead and, I don't know, let's always return 10. We've got very, very, very weighted dice. So if we save this, with any luck, the service is going to rebuild. Or the demo gods are going to be unkind to me. One of these two things will happen. That should have rebuilt, except I think I'm in debug, and that's why it is not triggering a rebuild. So let's quickly stop that. We'll come back to debug in a moment. So you'll see that it cleans up everything once it's done. And with any luck, our local Kubernetes cluster should be clean. If we start this up in normal mode, everything should be found because there's no code changes. It just deploys the applications again. So we'll just have to wait a moment for that to come up. Faster this time because the images are all cached, like the MySQL one in particular. We are just waiting for MySQL to come up and for Spring to go ahead and start. So what's happening there is because we are using stock standard Kubernetes descriptors, there's an init container for Spring, just a wait for MySQL check that you can put in. Don't start Spring before MySQL is running and available, because else Spring's going to just crash. If you've got any migrations with Flyway or anything like that happening, your Spring's going to fall over. So that's what the init container is doing. Everything's up and running. Angular's doing its thing, but if we change this to 10 now, you'll see that even though I've changed some code that is inside of a shared library, not inside not inside one of the services themselves, Skaffold and Jib understand Gradle dependencies. They understand what's happening in this multi-project. So just to show you how that's set up, if we go look at the Micronaut Gradle build, you can see that we have a implementation dependency that's a project. Micronaut is not in the Kotlin DSL because they just aren't there yet. You can see it here in Spring, looks a little bit different. But Skaffold via Jib understands this dependency. It knows that when a file has changed inside a common library that doesn't actually produce a Docker image itself, it knows that it needs to now go rebuild everything that's dependent on that. So you see it did that for Micronaut and for Spring. Did the build. So you see all a nice Gradle output there. And finally, did a deployment, waited for it to stabilize, and then started up Spring and Micronaut again. Now, if we roll our dice, we're getting straight 10s everywhere. So that is how clever it is. It makes us really, really smooth to work with. We run sort of file watching, and we do rebuilds all the time for the most part, and it just works really well. Anyone who feels it's too slow, they go ahead and turn on manual, but this works really, really well for the local development lifecycle. And the cool thing is you're accessing everything the way you normally would do it. So, I've also seen people, start to put in like cause annotations into their Spring projects because, like the front-end developers are connecting from somewhere else, or they are, writing really complicated webpack proxy development configurations just so that you can access the APIs from the web. And all this stuff goes away because you're sitting behind a Kubernetes Nginx ingress. Everything is on the same host. It's all just, routed via the different paths. And these paths can also look exactly like production. So it isn't like, in development, it's sort of like port, 8080 / this. No, it's just all the right port exactly the same way it would be in production or in your other environments. So this is really, really powerful in having a local development environment that looks identical. Let's go ahead and do some debugging. Let's put the code back, start this up in debug mode again. And what I want to show here is just, this is now, this application, when it comes up, is going to be running inside of Docker Desktop, all right, which is a VM. It's a HyperKit VM running in Mac. So my application's been deployed there, and we're going to remote debug it with zero worrying about, are the ports correctly mapped? Is all that stuff working? Because we've got the Code Cloud IntelliJ plugin in, and what that looks like is you basically give it a Kubernetes config. You give it a context in that config. In this case, it's just Docker desktop. This could be a config to a remote cluster. This could be a config to a cluster running inside your Vagrant VM. It could really be anywhere. And once you put this in and you've pointed it to a scaffold configuration file, it just knows what to do. So if we go ahead and put a breakpoint in here, we can now go and intercept a request that's coming through. All right, it's hit our breakpoint in our shared library. And we don't want, we actually want a 1D20. So if we look at our output, yeah, we got 1D20 there. Let's do it again because it kind of rolled us a 20. It's looking a bit suspect. The random number gods are not on my side tonight. There's a 15. So, we've got full debug into this application running inside a local Kubernetes cluster, which is inside a VM on our machine. Everything works from a developer experience point of view. From that perspective, if we go ahead now and look at the React application and the Angular application that are running, we can go ahead and hopefully okay, so here's just the default React application. And all I really want to show you here is if we make a change, hot reload should work. So let's just add hot in there, and with any luck, oh, they're the demo gods are not being kind to me. Oh, no, once again, I'm in debug. So let me stop in one. So one thing to remember, in debug mode, file syncing doesn't happen because you probably don't want to redeploy the application while you're busy debugging it. So that's just what's happening there. Debug mode you rarely use though. If you're debugging too much, it's probably something else wrong with your development process. So hopefully you're keeping that to a minimum. Let's just wait for this to come up and we will have our hot reload working. It would be interesting to see how many people here are deploying to Kubernetes in production. If you maybe just want to raise your hand in the participant window, that'd be cool. Cornel's not using Kubernetes. Oh dear. We can change that, Cornel. Anyone else? Who's using containers at all for even their local development? Cool, one person. Okay, so With any luck, hot reload works, and there we go. So hot reload happened. This works with the Angular application as well. Let's go do a change to that quickly. Oh, the application is terrible to look at by default. Let's find something at the top. So let's turn welcome into hello world. There we had hot reload work. So this is useful if you're doing, you know, API development. If you're just doing your front-end development as well, it works really, really well. I think I just want to show a little bit about Mysql running. So I think I had a quotes controller pulling some data out of a database. So let's just go do that. And there the demo gods failed me miserably. Huh. No, I just can't do Spring. That's all that the problem is. So this should redeploy now. So I think in general, this is a lot better if you're not doing everything in Spring. Certainly a Micronaut rebuild takes a fraction of the time, and then also a fraction of the time to start up. If you're using something like Quarkus, you can probably get hot reload working as well, which could be kind of cool for your API development. And then the demo gods are totally not with me. Why not? I think Flyway just didn't run. Oh well. Zero migrations. And that is probably something to do with my file naming. I should be allowed to do anything, but I think that about covers the demo. Should we go to Q&A? I'd love to answer some questions. You're muted, Cornelia.
There's a question from Rory that says, what is this production thing you mentioned?
Rory,
I think it hasn't been there in a while.
I know that it's been a super long time and you just get to play with cool web. We've muted you. We don't want to hear anything you have to say about your fun life of like never having to worry if something's running in production, uptime.
So I have a theory that they just took me out of production because I just was too disruptive. So I think the question that I have for you is, where do you see this being positioned with really production level container orchestration tools? So it's obviously not meant to replace Kubernetes or a test container or something that already is well established in here. How do you see it really coming to fruition in its kind of purpose-driven services?
Sure. So I'll just jump into test containers real quick. So we use test containers for our integration tests and unit tests, just to have the real environment, right there, and the real database in place. So test containers still form a part of the testing phase of your development cycle. This is not replacing that at all, and it doesn't it really doesn't play in that space. This is about giving you the same environment on your local machine that you would have in production, and all of the eccentricities that environment might have. So perhaps you're deployed with Istio inside of your production environment, and can service A talk to service B, right? And if you don't have the same Istio configuration running locally, you're never going to know that until you actually do a deployment, and you end up getting connection refused while trying to communicate from service A to service B. So you can completely replicate your production Kubernetes configuration, albeit smaller, on your local machine. And you can even use these same deployment scripts. So this is what we've done. We use scripts that look, or deployment descriptors rather, that look quite similar to this. Obviously, we run them through a customized step so that we can change a few things. We're using Azure DevOps for our deployments, and then finally we just take the scripts that come through the customize, and we use the native Kubernetes deployment task in Azure DevOps, and this gets popped through and deployed into production, and just works. So it's about, and the great thing is we aren't maintaining anything extra for the local development, right? All of the effort that goes into maintaining your production descriptors feeds back into this. So your developers always have a working environment, because if they don't, then production's not working either, right? And that's going to be a huge problem. Cool. Do we have any other questions?
Let's see. There's a question. How performant is such a setup on a dev machine? How much CPU and RAM do you need?
Yes. Let me let me finish. Let me finish with the last two slides, right? Because lunch is not free. Cool. So lunch is not free, but it's also not that expensive either. I mean, if people can afford to buy Rory a new laptop that he can stream himself to people all day, I think we can afford to give the real developers some real hardware as well. So look, we had to replace a lot of developer laptops because I found developers with laptops that had U-series processors. All right. Now, I think like it's all a little bit our responsibility to understand the hardware we work on every day. So a U-series processor is designed to run Excel quite poorly, right? The whole idea with the U-series processors, Intel hands them out. They're meant to go into really low-end laptops, and they have a variety of wattage that they can run at. So even though you see like what looks like a great processor, if you go onto the Intel website and look at what it can burst to, the manufacturer is actually running it at like, half or maybe 66% of that, because they've lowered the wattage so that the battery life looks better on their laptop for Excel, right? So you want to spend at least 50,000 Rand on a developer workstation or laptop. At least give them 32 gigs of RAM. Get an Intel H or K series processor. just spelled correctly, unlike what I've done there. Throw in a terabyte of non-volatile memory, because if your developers are working with containers or virtual machines, you want them to have like be juggling what they can have stored and running and local at any one time. And because we like eyesight of our developers, we give them 4K displays so that they can have crisp, clear things. So there's a few examples of this. The 2020 edition of the Dell XPS 13 is quite a beefy machine. It can go up to 32 gigs of RAM. Plugs really well into external monitors. You can get a Dell XPS 15 if you need a little bit more. If you're feeling adventurous and you want to do the order, you can get a System 76 adder. What's really cool about this is, one, you can push it all the way to 64 gigs of RAM. It has, you know, the great processors, the non-volatile memory, 4K display, but it also runs, you can also get an NVIDIA RTX in it, which is cool if you need CUDA cores for any kind of machine learning applications. Probably not so relevant to this crowd, but it's certainly quite useful. But it's running Linux natively, which means you don't need a VM to have your Kubernetes in play. There isn't like Docker Desktop that's running a VM, or there isn't on Mac Minikube or Docker Desktop, or you don't need to have a Vagrant set up. You can bring up Kubernetes, either K3s or any other flavor, natively on your operating system, which means that things are just a heck of a lot snappier. It's definitely a lot faster to do it that way. So if it was my choice and I was doing exclusively development on Kubernetes, I'd probably go for native Linux running on something like a System 76. And finally, a MacBook Pro. You can get this configuration with everything. It also goes up to 64 gigs of RAM, which is super great, by the way. That's what I'm running, and it is smashing. Terabyte of non-volatile, 4K display, a proper processor with all the cores that you could want. So definitely worthwhile, I think, spending the money and having your developers productive. And finally, are there any alternatives? So, you know, Skaffold was created by Google because they've got thousands of developers that all work in Kubernetes every day. They use a lot of Java, Python, Go, and also Node, which is why it's what Skaffold supports out the box in terms of debugging integration. You know, the build systems kind of reflect this as well, although now with build packs, it's really becoming very open. And the really great thing about Skaffold for me as someone who works in the JVM is the jib integration, because it's just really, really smart in how it understands dependencies, what's changed. If you're using something like Bazel, then I think that you'd get that as well. I think you can tell this is a Google favorite, considering it supports their build system. So, and it's true open source in the sense that there's no enterprise anything behind it, right? So this is open source. There's no business model behind this. They don't want your money for it. About the only thing that kind of would make it a little bit good for them is it's got some GCP integration, but this is more from the internal use than them trying to get you to use GCP. You can point this at any remote Kubernetes cluster. That said, there are some alternatives. There's Tilt, which is a startup based out of New York. It's not using plain YAML to do the description, which, you know, to me, I don't need another build language. I'm quite happy with YAML. I think if you're using Kubernetes, you're using YAML anyway. So it's just an extension of that. If you want to have any of your folks that are maybe more focused on production or DevOps working with this, you know, YAML something they understand. They don't have to then learn Starlark, which is like a Python-like language. And then there's also Garden. Now Garden is a little bit different because it does work on the developer side of the pipeline, but it also is designed to work all the way through to production. So Garden is a little bit different. And the other big difference is that Garden was built in TypeScript, and they realized the error of their ways. So now they are trying to move a lot of it over to Golang. Skaffold and Tilt are both built in Go. Tilt, I've got it as not supporting Windows. It does have a Windows release candidate out. When I built this slide, it was still quite beta earlier this year, and they were kind of like, use it, maybe it works. So they're getting a lot stronger with supporting Windows, but you know, I think it's quite clear that Skaffold's a heck of a lot more popular. It's really active. They're blasting through lines of code, which is interesting, but they're net removing lines of code, which is always good. And they've got, you know, it's used by Google, so it's going to be supported forever until Google decides that they don't do builds in Kubernetes anymore, I think. So that makes it quite good as well. So that was a bit of a long answer to a question. What's next? Any more questions? Oh, there are. Wow, there's lots. Okay. Yeah.
So how much have you gained in developer productivity?
Wow, stacks.
Mm-hmm.
So we've, you know, so we had vendors supply developers, and we've been onboarding more and more over time. We've had some that didn't work out and we had to roll off. But when a new developer comes on board, it takes them about 30 minutes to have, you know, whichever part of the system they're working on running locally. They can start to run through it. They can start to contribute code changes. It's really, really quick. So that was a combination of Vagrant, number one, there because we have a bit of a VPN setup. So the reason that we actually went with Vagrant is because the VPN we have to use into the organization cuts off your internet access. So it basically rewrites your default routes. If you're on Windows, you can't do anything about that. The VPN client doesn't, like, it just keeps refreshing the routes. Same thing on a Mac. If you're on Linux, if you're one of the fortunate Linux developers, you can install OpenConnect, and you can set your routes however you want, and it's fine. But for everyone else, that was a problem. And shifting to remote, it means that, you know, now we're working off of Zoom and Teams and Slack and whatever other remote, you know, interaction tools we're using. So getting cut off from the internet so that you can be connected to, you know, some archaic legacy systems as part of your needs for development means that we needed to kind of put the development into a VM and run, because it's a Linux VM, we could then just run the VPN inside there, and that runs, and the rest of the laptop is connected to the internet. So we went with Vagrant. Since then, we've actually spun out a smaller Vagrant VM, which is just a Linux, just a simple Linux machine. It takes like 256 megs of RAM, and it's just a router and a VPN, so that now we are running Skaffold locally on Windows or on Linux with Docker Desktop. On Windows, we have a few of the devs on Linux, and they're just running the VPN straight. And on Mac, we're also using the little Linux router VM to kind of get around VPN shenanigans. Don't tell the security department; they'll probably send people in black vans. And then the other thing we did
Yeah,
is ngrok, so that we could kind of share work, whether it's with the product owner, just having the product owner have a look at what's on a local developer's machine from across the world, or if, like I say, the mobile developer wants to connect to a backend developer's API, they could share it that way. So it's definitely gained us a lot of productivity. Onboarding a new developer, like I say, is half an hour, which is really cool. Everything just runs. You never have to worry about, you know, I'm sure everyone, I'd actually love to get a hands up of this. Who's had to like either write or follow some document on Confluence or some other god awful wiki when they joined a new project or a new company that taught them how to bring up the system? If you can do a hands up in the participant window, let's see who's had to go through this in their life. So this is completely gone, right? It doesn't exist. A new developer gets on board. They run a handful of commands that are sitting inside a README inside the source repository. About the longest part, probably the longest part of onboarding is getting them an Active Directory account, so I can add them to Azure DevOps and they can check out the code. That's probably the most complicated part of developer onboarding. So I think it saved a lot of time. I think it saved a lot of time later on. You know, once we got the hardware for the environments, and we were able to, you know, have, you know, dev testing, production. We had already built all the Kubernetes descriptors. So there was some tweaking. I'm not going to lie there. It's not like they were like 100% perfect out the box, but we were like 95% of the way there with our Kubernetes descriptors, and everything just worked really well.
Yes, I know from experience trying to connect to a weird VPN while you're trying to configure the Kubernetes and then trying to search for answers. It can get fun. So you want to do this in the comfort of your own home. Even if you're building the descriptors, it should make the life a lot easier.
And then
This is good.
maybe then I think when I asked if anyone's running Kubernetes, there weren't any hands up in day-to-day work, but is anyone going to be running Kubernetes in the future?
Yes.
Or do they know this is going to happen? This is a really great way.
We've got a few systems in progress.
Mm-hmm.
Yeah, so I was working on a system. We were trying to actually run LiveRay inside of Kubernetes. And then we discovered that the way LiveRay works with its plugins means that because it requires a restart of the host, and when that happens, Kubernetes gives you a brand new image. So we could never get the some of the plugins properly installed on LiveRay.
Okay.
So we had to move that to a plain VM again.
So for that, what you could have done is actually use init containers. Probably would have been what you needed to do. So Kubernetes has this really cool concept of init containers. So you can have one or more init containers. They run in the order that they are defined. They can be, and this is the part that's really cool, is they can share volumes, right? So what I've done before is with these is bringing up a couple of things. So bringing up Redis in a Sentinel cluster. I built some Kubernetes descriptor for this back in 2018. And you kind of have to bring up Sentinel and Redis together. And the other one is Mongo, which I had to bring up in a cluster as well. and that you have to bring up Mongo first, right, and then tell it that you're going to do a cluster, right, and then you have to restart it after that. So part of the inner containers is you can basically, in that case, load up the data directories, or if you have plugin directories or whatever, you can have things go inside them, and then when the main container starts, anything that changed on the file system is there and it's present. So it's actually really, really useful, and it's a way to get your service into the right state.
Interesting that the so-called Kubernetes experts on the project didn't know about this. And, yeah, it was my first Kubernetes one, so that would have been useful to know.
Next time, just ping me on Slack, Cornelia. that is the answer.
Thanks for that one. That looks like all the questions. If there's anybody else, raise your hand, or forever hold your peace. This is being recorded, and we will upload it to our YouTube channel as soon as I have had an opportunity to create the video, and it should be within the next day or so, and I'll post the link on our channel. If there's any parts you want me to cut, you can send me a list. Thank you everybody for joining, and
thanks so much.
We hope to see you next time.
Oh, and if you want to ping me if you have any questions about this that you think about later on, you can grab me on ZA Tech, or just pop me an email to justin@wire.dev, and I'm always happy to talk technical topics. It's like my favorite thing, so don't be shy.
Great. This was lovely. Thank you, Justin. And good night, everybody, and stay safe.